Good morning, everyone. I hope that you guys are having a nice morning. So today we're going to talk about arithmetic sequences. I'm going to lay some foundation work for the next few sections. The chapter itself should go fairly smoothly through the first half, so it shouldn't be a big deal for you guys to not have me. But if it is, feel free to send me emails. I won't guarantee quick responses because I'll be doing other things during the day, but I'll try to make sure that everything's taken care of, and then for sure when I get back on Friday, I'll take care of any problems that anyone has. So first of all, a sequence is a pattern of numbers. There are a lot of different kinds of sequences that we're going to work with. And we did talk about them back in 8th grade when we were working through Algebra 1. There's two major types of sequences that we're going to work with, and then there's some more interesting ones that end up falling in every once in a while. The big two are arithmetic and geometric. Both of which we're going to work with over the first 4 lessons of the chapter. Arithmetic sequences are sequences of numbers or number patterns where we add between terms. Examples of arithmetic sequences would be things like 1, 3, 5, 7, 2, 4, 6, 8, 5, 11, let's see, 17, 23, etc. So this one is a +2, this one is a +2, and this one is +6 between terms. Now that addition or subtraction factor between our terms is called our common difference. Now, like I said a second ago, the common difference could also be a subtracted difference. So another example of an arithmetic sequence could be 3, 0, -3, -6. You'll also notice with most of my sequences, I had a bunch of different starting points. This one happens to start at the same value as its common difference, but none of the rest of these do. This one started at 1, this one started at 5, this one started at 3. That initial term or starting point of our sequences is called A1 or term 1. As we move forward, each term in our sequences will be named by an A and then a subscript. So A2 would be our second term, A6 would be the 6th term, and ultimately, as we start creating formulas AN will represent any term in our sequence. Now, when we're working with ANs, what we're doing is we're looking for specific points in a sequence. With arithmetic sequences, it's not as difficult to find specific points along the way unless they get really, really far out. So to find the 5th term or the 7th term or the 12th term in a sequence, it's not very difficult when you're just adding each time. You just add, and you end up there very quickly. But to find the 200th term or 156th term or 5,427th term, it would be very difficult to just jump out to that term or to sit and add each time. It's possible to do so. With all of these, it's possible to do that. You could sit and list out every single term and count them upward to that point, but you're much better off using a better system. Geometric sequences are sequences where we multiply between terms. Now we're going to get into them in much more detail later on, but you need to understand the difference right now. So a geometric sequence could be 2, 4, 8, 16. You'll notice the very sharp contrast between the arithmetic sequence and the geometric sequence. So because we're multiplying between terms, in this case this is a times 2 sequence, we could also do something like 1, 3, 9, 27. Or you could be multiplying by a small number like 64, 32, 16, 8, etc., which is multiplication by half, and this one is multiplying by 3. Geometric sequences grow very, very quickly or shrink very rapidly in comparison to arithmetic sequences that are very uniform in their growth and descent. The bigger picture here becomes the connection between this material and then our graphing lessons from before. Arithmetic sequences will all follow a linear pattern, and the formulas that connect with arithmetic sequences are linear formulas, with the common difference directly connecting to the slope of the graph it creates. And our initial term being related to our y-intercept, but not directly connected to it. Because we're not looking at this from an 8th grade standpoint, and you're not going to be tested on being able to connect arithmetic sequences to linear equations like you were back when you took the 8th grade MCA test, we're not going to spend a whole lot of time talking about this relationship. But for those of you who do remember back, the connection is that you go one step before your starting value to get your y-intercept. So A1 is not our y-intercept, it's actually back at A0, that's our y-intercept. But we're not going to spend a lot of time focusing on that. Hopefully all of this is coming together pretty nicely for you. I'm going to leave that side of the board open so that if people got things to copy down yet, and I'm going to clean off this side of the board and talk about the formula that we're going to work with to find any term within an arithmetic sequence, after I talk briefly about following patterns and recognizing. So let's say that we have the pattern 5, 7, 9. One of the big questions that the book will ask us to do is move forward in our pattern. So what are the next 3 terms, or the next 5 terms, or the next 7 terms? Now, these patterns are really easy to see. 5, 7, 9 is plus 2, plus 2, plus 2. So my next 3 terms are 11, 13, and 15. if I don't know what the next term will be, especially when we get into geometric, the key is to work backwards. So I know I'm adding each time in this pattern or subtracting each time if it's going downward. So I always just subtract backwards and that'll give me my common difference. So if I take any given point and subtract backwards, so 15 minus 13 is 2, that's immediately my common difference. But now I need to be able to get to like the 20th term, or the 25th term, or the 27th term, or whatever. Let's go simple. Let's just look at our 6th term, which we already have. So the 1, 2, 3, 4, 5, 6th term in our sequence is 15. We need a dedicated way to be able to jump immediately to that 6th term. We know we're going up by 2's each time. We also know that we started at 5, and we know from 5 to 15 is a movement of 1, 2, 3, 4, 5 terms. And that's a really important key here. Because we start at 5 and we're moving to 15, even though we're looking for the 6th term, we've only moved 5 terms from where we started. And there's where our formula ties into all of this. To find any term, an, we need our first term, and then we're going to add the number of jumps that we make, which is the term we're looking for, minus 1, because if I'm going to the 6th term, I've only actually moved 5 places. If I'm going to the 20th term, I've only actually moved 19 places. Times our common difference, because that's how many jumps I'm going to make from where I start to where I end. So in our case, to find the 6th term, we need our first term, 5, plus n minus 1, which would be 6 minus 1, in other words, 5, times our common difference, which is 2. 6 minus 1, 5, times 10 is, or times 2 is 10, plus 5 gives us 15. So our A6 ends up being 15, which we knew already. But now we have the ability to do it with any set of information that the book wishes to give us. So let's say that the book gives us the sequence 9, 28, let's see, it would be 47. So now we need our jump here, and we have our starting point. Then we need a goal. Let's get to the 14th term. First off, I'm going to subtract backwards. 28 minus 9. 28 minus 9, borrow the 1. 18 minus 9 is 9. 19 in that jump. Plus 19, plus 19. Now we're going to go to our 14th term. So A sub 14 equals starting term 9 plus 14 minus 1, 13 times my common difference, 19. Fourteen times 19 gives me 266. So A sub 14 is 9 plus 266, which gives me 275. That gives me the ability to jump to any point in any arithmetic sequence as long as I use my formula. So very quickly, I want to grab just a couple of problems from our homework assignment to get you started. And then we're going to go ahead and let you work on this, or I'm going to go ahead and let you work on this, and hopefully it goes well. So we're on page 652. The first problem I'm going to work is problem 16. This first grouping of problems just asks us to find the next three terms. In order to do so, we have to identify our common difference. Next four terms, I'm sorry. So we're looking for our next four terms. Problem 16 gives us 9, 16, 23. The first thing we need to do is subtract backwards so that we have our common difference. 16 minus 9 is 7. So my common difference is 7, plus 7, plus 7, plus 7, plus 7. So the term after 23 will be 30, and then 37, 44, and 51. That gives me 4 new terms, and that problem has been completed. The next problem I want to work on is problem 24. Problem 24 gives us a bunch of pieces and asks us to find the given term. So A1 is 3, D is 1/3, and it wants me to find the 12th term. That's what n equals 12 is telling me. I'm going to climb by 1/3 each time, which is not going to be much fun, but it is what it is. I start at 3, so I'm going to find the 12th term. My first term is 3 plus 12 minus 1 is 11 times D, which is 1/3. Oh, D is actually 7 on this one. Let's get that fixed up. I have it written wrong. So A1 is 3, D is 7, and N is 14. I mixed two problems together. Sorry about that. Let's walk through it again. A1 is 3, D is 7, and N is 14, which means that I'm adding 7 each time, and I'm going to the 14th term. So while I'm at it right after this, I'll go ahead and do problem 26, which is the one with the 1/3 in it, so that you have that down. All right. 13 times 7 is 91. So I have 3 plus 91, which gives me 94. A12 equals 94. Hopefully I didn't screw up too much there going through that. But let's look at problem 26 now, since I intermixed that, and I want to get a good sampling in here. A1 is 5, D is 1/3, and N is 12. All right. So this time I'm going to climb by 1/3 each time, and I'm going to go out to the 12th term, but I'm going to start at 5. So to find my 12th term, I'm going to do A1, which is 5, plus 12 minus 1 third. 12 minus 1 is 11. Times a third. 11 times 1/3 is 3 2/3. And I'm going to add 5. 5 plus 3 2/3 gives me an 8/12 of 8 2/3. Hopefully that'll give you all enough of a start that you can piece those things together. I need to deal with one more thing. Before I let you go, to make sure that you have all the tools you're going to need. The very last piece of this is to be able to find arithmetic means. Which is basically just a really fancy way of saying gaps in my sequence. So if I had 55 and then 3 gaps and then 115. Many of you will be able to piece together what this pattern is going to be already. This is problem 37 from your homework, by the way. However, I want to be able to work through this with you so that everybody can, and I really want you to be able to use the formula to do this, because when you do it with geometric means, it's much harder to just, in your mind, figure out what's going on here, what the pattern is, and what you need to do moving forward. So, the key is to run back to the formula. A1 is 55. I know that my n value in this case is 1, 2, 3, 4, 5, because I'm walking out to the 5th term. Now, on some of these problems, they don't start you at the very beginning. Start with the first number you have, end with the last number you have. Ignore any spaces before or after until you're all done. And if you have trouble with that, just ask me when I get back, because there's a couple of them that can be a little tricky that way. Otherwise, lean on your classmates for a little bit of help on them. But I think you guys will do okay. So now I know that my AN in this case is 115. So I'm going to come in and use my formula to my advantage. So AN equals A1 plus n minus 1 times D. D is really the X factor here. Once I can find D, then I can put together all of my means. AN is 115. A1 is 55. N is 5. 5 minus 1 is 4 times D. I'll step back and let people write for just a second. Make sure you have time to fill this in. Be really careful when you do this math. That 4 is multiplied to the D. It has to be moved away properly. And I know you guys can do that, just don't leap into something like trying to add the 55 and the 4 before you move it back across. So the first move has to be to deal with the addition, which is to subtract away the 55. I do 115 minus 55, which should be 60. Yep. Now I have 60 equals 4D. Now I can divide off this 4 and find out that my common difference is 15. Now that I know that my common difference is 15, I can jump through each of these slots. So 55 plus 15 is 70. 70 plus 15 is 85. 85 plus 15 is 100. And 100 plus 15 is 115. And I'm okay. I have everything I need there. Alright, as long as you have that all down, you can get to work. Your homework is on page 652, problems 16 through 40. It seems like quite a bit, but the first chunk is just finding the next 4 terms, and then the next chunk is practice using the formula. So it's only the last 4 that are like this with the arithmetic means that might be particularly tricky, but take your time, help each other out, and make sure that everybody's successful.